আচ্ছা, ওটা থাক। এটা দিয়ে শুরু করি আমরা। অন্য রং দিয়ে লিখবো? অন্য রং দিয়ে লিখতে বলছে তো? গোলাপি আছে, সবুজ আছে, বেগুনি আছে, কোনটা দিয়ে লিখবো? না, নতুনটায় হলুদ নেই। শুরু করবো? Okay, so let's before lunch I mentioned this theorem of Landau's, and we can try to prove this now. Okay, so what does it say? I have a series alpha of s, which is equal to n to the power s. Okay, and its abscissa of convergence is finite. So if an is positive, okay, then you should show that alpha s is not analytic at sigma c. So can we try to prove that now? Is it clear what we should do? I mean, you see, if you can already assume that n is large, because if you take a finite series, here this is over n going from 1 to infinity. Yeah? Yeah. Okay, so this is, here n is going from 1 to infinity. And you know that if you take a finite series, if you take an n to the power minus s, and from 1 to capital N, then what kind of a series is this? This one? This is entire. Yeah, we know that. So that's okay. Is entire. I mean, so you can take your n to be large. So how do you want to prove this? Will you try to do it yourselves, and then I can help you? So can you tell me what kind of ideas you have and how you wish to? Like, we know that sigma c is finite, so you can actually take sigma c to be 0, because it just means a translation. You don't lose anything. You can consider sigma c to be 0. Yeah, that's okay. And then can you say why there is a singularity? Why do you expect a singularity? Can you think about it? Are there some ideas? Who has an idea? You have an idea? What would you like to do with this alpha S? You want to take the radius of convergence, but to take the radius of convergence, you want a domain of convergence, and you want to express this in some way. So why don't you express this alpha S as a power series? Try to express alpha S as a power series. That is possible. So try to do it. So first thing, anyway, I suggest is that we can take sigma c to be 0. How can I take sigma c to be 0? As I told you, by pushing the line. So you, by replacing, so what should I replace? So I already have an here, and this an, if I replace it by an, what should I, how would sigma c become 0? So if I take an, n to the power minus sigma c, yeah, nothing is lost. We can assume sigma c equals to 0. There's no harm in that. Till here, that's okay. Do you agree with me? Then what should I do? So I want to show that alpha S is not analytic. Yeah. So there is a singularity. Where should I show the singularity? At 0. Yeah. So let me assume that it is analytic and find a contradiction. Yeah, do it. So to let alpha S be analytic at S equal to 0. So what happens if I have analyticity at S equal to 0? Can I find a contradiction? I mean, what does it mean to be analytic? Can you use the definition of being a function being? Yeah, so construct one, construct a neighborhood. You will use it afterwards. First, you need a domain. So what will be your domain? This is 0, yeah? At S equal to 0. You are assuming it to be analytic at S equal to 0. So that means that there is some convergence. So alpha S then has to be is analytic in some domain. Yeah. What kind of a domain will that be? D, suppose, yeah? I mean, not enough to call it D. How are we going to define this? Function is analytic at S equal to 0. So it means it's going to be analytic somewhere, yeah? And like what? So S equal to 0 means sigma has to be greater than 0. Is that okay? Is sigma greater than 0 enough? So D is equal to S, okay, where sigma, S is sigma plus sigma greater than 0, and somewhere else. It's not only at sigma greater than 0, but also at, yes, yes. How do you want to define it? It's a good way of good way of writing it. That's going to give us, you know what we are trying to do. We are trying to show that there is a contradiction. Yeah. So we are assuming alpha s to be analytic, and we will show that somewhere this doesn't work. Yeah. So you need something else for your domain. This is not enough. It's not only sigma greater than 0, but also. So you're not allowed to answer. You can't help them. You can help, but not. But you. Okay. So what do you want to do? Now, you want to quantify this. It's not, it won't help to say s greater than 0 and s less than, sigma greater than 0 and sigma less than 0. So rather take s to be less than some delta. Okay. Some delta. And what is this delta going to be? Delta has to be positive. Okay. With delta positive and small. What by small, you understand what I mean by small? It means I can make it arbitrarily small. Yeah. So it is analytic in this domain. Now you do what you want to do. Write a power series that is equal to 1. So expand alpha s as a power series, okay, say at s equal to 1. And how does it look then? This is, yeah. You can take it anywhere. Yeah, and then you are going to move it. I mean, it's better to keep it at 1, because if you keep it at 1, then you can, well, write the power series and you will know what I'm talking about. How does a power series expansion look? Do you remember this from your school days? Oh, I don't know when did you do these things? Long ago, I suppose. Power series expansion and things, yeah. But yeah, so this is a power. So right, so help me write the power series expansion. Alpha s should be equal to what? Should be some kind of a sum, an infinite sum, in fact, and some kind of coefficients. Let me call them ck. And then as I'm saying s equal to 1, I'm going to write s minus 1 to the power k. Do you agree with me? And I will let this k go from 0 to infinity. Can you tell me what ck is? So you will take your kth derivative. This is called, which is not particularly important, but yeah, this is possible. Do you agree with me? This is possible. Now what do I do? We have this, yeah? Louder, please. Do you need that? I mean, I think simpler than that. You don't really care for what exactly the CK is. Yeah, this is not what interests us at the moment. I mean, for this question, for this particular thing, what interests us is that there is a singularity, and so singularity will come from where? It cannot come from this sigma greater than 0. So it's going to come from here, this delta. Yeah. So let us try to express this. So what is the radius of convergence? What is the radius of convergence of this? It is the distance, since I have said power series at s equal to 1. So the radius of convergence okay, according to you, what should it be? Of alpha s, of course. This is the distance from 1. This 1, okay, is the distance from 1 to where? Exactly. From 1 to the nearest, okay, so singularity of alpha s. Okay. Now can you tell me how you are going to use this? Since the domain of convergence is here, where is the singularity? There is no singularity inside the domain of inside the domain of convergence. That would contradict the definition of the domain of convergence. Yeah. So the nearest points, what are this? This is what you said. Yeah, the nearest point. You told me this is the nearest singularity. But any singularity is not in D. So what is the nearest singularity? Outside D, of course, because it cannot be D in. What is the nearest singularity outside D? Yeah? Look at this. Absolute value of S is less than delta. Yeah? So the nearest singularity will be, for example, yes? Someone has an idea? Yeah, if you take I, that will do, right? I delta. Yeah? Anything, any I delta will do. This is the closest one. Yeah. Now, can I write this delta? So this is the nearest singularity. Now, therefore, what is the radius of convergence? The radius of convergence is greater than, so the radius of convergence will be exactly. Is it equal to? Is greater than or equal to? Is greater than or equal to square root of 1 plus delta square. Is that clear to everybody? So this square root of 1 plus delta square, delta is positive. So this is positive also, and it is something like 1 plus delta prime, some delta prime. And do you now see where the contradiction will come? The contradiction will come from these 2 points, that alpha s is analytic at s equal to 0. The radius of convergence is greater than equal to 1 plus delta square, square root of 1 plus delta square, which is 1 plus delta prime. So now let's go back to alpha s. All right. So alpha s, the writing of alpha s, the way we wrote it in terms of, there it is. Yeah. Then alpha s write it again. So see what it looks like. Alpha s is some ck times s minus 1 to the power k. Okay. So alpha s I want to write this as a sum. So instead of ck, I write all those things. What is it? Alpha k. So the sum is over k. Sum is over k. 1 minus s to the power k and factorial k. Yeah. Factorial k summation of what was alpha s in the beginning? It was a n. Yeah. So I'll write this back again. So I get an an log n power k because of this k. Okay, log n power k and divided by n. The sum is over all n. Okay. Now your s, this s, here we've taken the absolute value. So if s is less than 1, if s is less than 1, then all the sums here, all the terms here are non-negative. And then my life is very nice. Yeah, I can change summations, I can do everything I feel like doing. And so I do that, do everything I feel like doing. And okay, just one thing I didn't say. So, so this is for here. This is 1 plus delta prime. Yeah, the radius of convergence is 1 plus delta prime. I should say that. So s minus 1 is less than 1 plus delta prime. Okay. So if s is less than 1, all these terms are non-negative. Okay. So change everything that suits you, a non-negative, and so whatever I do now is allowed. So yeah, s is greater than, s is less than 1 and greater than minus delta prime. Delta is positive. So alpha s is equal to, let's write it now, this expression that we have. There. Alpha s is, let's bring out an by n. Okay, if I bring out an by n, then I will get alpha s. So okay, this is sorry, an by n. Okay, then what's left is k. What's left is k. So k goes from 0 to infinity. Which are the terms that are left? 1 minus s to the power k. Okay, this term, then log n to the power k, whatever is being summed over k. Is there anything else? Factorial k. All right. Alpha s is equal to this. And that's okay. So I get an by n over n, and this is exponential 1 minus s log n. Yeah? This is equal to summation a n to the power s. Okay? And where does this converge? Where does this converge? That's what's going to give me the contradiction. Where does this converge? Where is the convergence of this? Yeah, try to tell me. Which s? S equal to? It should be half of the delta, right? And this is not 0. Because delta prime is 1 plus delta. It's positive. Delta is positive. So this is a contradiction. Okay. This was Landau's proof. Okay. I thought we could do another exercise first on the sort of things we did in the beginning today. So, I mean, this is really a lot of analysis. Let's do one that is more number theory. Yeah. So here's a question for you. You remember that this morning we talked about groups and cyclic groups and all sorts of things. So I would propose a question of that kind. So, yeah, before doing that, do you know Bachel's theorem? You can do that first. So, which is going to be needed. So, if you don't know it, so this is, it might look out of context, but it is not. This is Bachel's theorem. It might not be known by this name by in all texts. So if I take D to be equal to the GCD of M and N, then MZ plus NZ is equal to DZ. This is the theorem. Have you seen it somewhere? These ideals? Yeah? You have seen this? You know how to prove it? Do you know how to prove it? Yes? You want to do it? Come. Is everyone sure that he or she knows the proof of this theorem? Or can reproduce it? Because this theorem we will need for the next exercise. So you know what an ideal is, of course, because you didn't live for so long without knowing what an ideal is. So suppose I take, so an ideal is an additive subgroup of Z under multiplication. So, so what are the steps to show this? Yes, we will use Bezout. Apparently, no, apparently Bezout's theorem should not be called Bezout's theorem, say some people, but never mind, go ahead. Is it? Yeah, but is yeah. Yeah, and the other way around? I mean, how do you know? How do you know that if you have, so the first step that you would have to show is, if I have an ideal in Z, okay, let I be an ideal of Z, then I is exactly, then I is equal to K times Z. And what is this K? What is this K? Which K is it? Is the smallest positive element of I. Okay, where K is the smallest positive element of I. And why is this true? Okay, you have to speak louder, otherwise I can't hear. Uh, uh, yeah, Euclidean division. Yeah, that's fine. So it's clear. One way it's clear that K of Z is a subset of I. Yeah. Why? Okay. Why? Because Kz is a subset of I. But that's not enough. Should I write only in orange, or is it okay if I write in green or whatever? Anything but white. Okay. So Kz is a subset of I. K belongs to I. Okay. Now you use the Euclidean division of any A. So let A be an element in I, any element in I. I'm not asking, and you divide it by K. So A is equal to BQ plus R. Okay, and this R is strictly less than K. It could be 0, but it cannot be K. You agree with me, yeah? So R is equal to, what is R equal to? R is equal to A minus, I'm dividing by K, KQ plus R. So R is equal to A minus KQ. And that means that R is equal to 0. Therefore, I is exactly equal to Kz. Is that what you meant? Is that was your argument? Is this over? Yes? No, it's not yet over. Because the second point you have to note is that mz plus nz is an ideal. Okay, that's easy, right? And the third thing that you have to show is that mz plus nz is equal to k times z. Okay. So k is equal to the GCD of M and N. All right. So since M and N are in KZ from the first part here. Okay. So M and N are in KZ. All right. Since M and N are here, K divides the GCD of M and N. All right. So now again use the existence of U and V such that K is equal to UM plus Vn for some U and V. Is that okay? And so Mn divides K and K divides Mn and Mn divides K means K is equal to Mn. Okay, so here is a proof of what? Of Baché's theorem. Good. Which means whenever required, you can write this. All right. And we are going to use this theorem now to do an exercise which is of this kind. This is the exercise. This will look more like what you know. You remember your this. So exercise. I take a prime which is greater than 2. Okay. And for all d which is greater than equal to 1, I define a function psi of d to be the number of elements, say x, in z by pz. Okay, for a prime you take the order of x is equal to d. Okay, so this, does it remind you of something? Another very well known function. This is an arithmetic function that is very well known. Euler, yeah, for example, yeah, and in fact we are going to show we are going to use that, yeah. So show that, see if you know, if this strikes a bell. Show that sum of psi of d divides p minus 1, this is equal to p minus 1. Does this strike a bell? Yeah. So you can use, now you can use Baché's theorem. Yeah. In fact, wait, the aim of this exercise, what is the aim of this exercise? Is to prove that z by pz star is cyclic. Okay, so you can't start by assuming that it's cyclic. Okay, you can't assume that it is. So, so I will divide this exercise into a certain number of parts. First of all, we show this. Okay. Second thing is, let y be an element of order exactly d. Okay, that's the D. That D. Okay. Where is Y? In Z by PZ star. Okay. Show that this equation x to the power d minus 1 is congruent to 0 modulo p has exactly d solutions. That's not enough. What are they? What are these solutions? I mean, explicitly, can you write down the solutions? And yeah, they are. Show that each element of order D is one of the, and here is what you said. You said this. You said phi D, Euler phi function, phi D generators of the group. Okay. Therefore, part C, show that phi of D can be compared with psi of D can be compared with phi of D for all D, and deduce that Z by PZ star is cyclic. So this is something that's linked to the first part of what we did today. You remember where we talked about and it doesn't require any big things, so it's a nice exercise to do. So can you try? I mean, it's been broken up into parts. So the answer is not since Z pi PZ star is cyclic, therefore it is cyclic. It is, we don't know. At the moment we are people who don't know that Z by PZ star is cyclic, and we want to prove it. Huh? Yeah, but the question is not just the last sentence. Prove that Z by PZ star is cyclic. Then you would do whatever you like to do. But the question is to go using this function, this psi of D, to show that Z PZ star is cyclic. So first thing which you can do is part A, how many elements are there in Z by PZ star by using Beshe's theorem? Can you tell me? Huh? P is prime greater than 2. Okay, P is prime greater than 2. So how many elements are there in Z by PZ star? Of course, you know how many elements there are in Z by PZ star. Can you do that by using Beshe's theorem? That's the question. Yes. Huh? So what is your little m and what is your little n? You want to say that mz plus, huh? N is p, okay? You said some things and I'm not sure everything is clear to me. I mean, that's not your fault, it's probably my fault. But so you have P, and since P is a prime, therefore, whatever you, unless you take a power of P or a multiple of P, it's going to be prime to P. So you get, for whatever M and you take Z plus PZ, and then you get, yeah, P minus 1. So using Bechet, you get, so solution here is, using Bechet, Z P star is equal to P minus 1. Okay? Because we asked you to use ZP1. Okay? Now you know that the order of an element in a group, I mean, we have nice finite groups and everything, it divides the order of the group. Okay? So that means that the order of the element, which is D should divide P minus 1. Yeah? And therefore, D dividing P minus 1, psi of D is P minus 1. Okay, all the divisors. You take all the divisors, the sum of all the divisors, and then order of an element, order of G divides order of G, where G is an element of G. Yeah? This is Lagrange. Now for the second part. You want to show that this equation, z power x power d minus 1 is congruent to 0 modulo p. This has exactly d solutions. Why would it have exactly d solutions? Can you tell me? Is there something that's obvious here? Not that it has exactly d solutions. That's not obvious. What is obvious is that there are at most d solutions. It's a field. Yeah? I have a field. Therefore, there are at most d solutions. Yeah? So part B, now that I know Bechet, I'm going to remove Bechet from here. So if you take the powers of y here, where is my y? Y is an element of order d. So if I take powers of d, they are all distinct. Yeah? Because order of y is equal to d. Order of y is equal to d. That means that d power k, for k going from 0 to are distinct. Yeah? They have to be distinct, otherwise the order would have been smaller. Modulo p. All right? All of these are solutions of this equation. Okay? And we know that do you agree that they are all solution? But we know that this equation can have at most D solutions. Okay, since Z by PZ is a field, one has, I don't know if it has exactly, but I know that it has at most D solutions. Is everyone in agreement on this question? Okay. Yeah, sorry. Y to the power k, yeah? A distinct mod p. And this has at most D solution, yeah? So that means that since this is a field, yeah? So if I take this set, y power k, yeah, with k going from 0 to D, what is it? These are the roots of this polynomial. Oh, do I have to stop? Are roots of the polynomial x power D minus 1 in Z by PZ star. All right? And what is the order of D by of y by k? I still don't know that the order of y by k is exactly what. What I know is it's something d divided by the GCD of kd. So my aim is to show that the GCD of kd is equal to 1. Now again use theorem of Bechet and you see that kd is equal to 1. Why? Because y power k and y, they generate the same subgroup. Y power k and y, they generate the same subgroup. Okay? So k power k and d are, can I take 2 minutes more and finish? Okay. Okay. So this is part B. Where is my part C? Here. Show now that psi of d is less than equal to phi d, and hence deduce what you know, but you didn't know how to deduce, that Z by PZ star is cyclic. So part C says, okay, so if D does not divide P minus 1, then what happens if D does not divide P minus 1? Then psi of D is 0. Yeah? So let D divide P minus 1. I don't want the case where psi of D is 0, right? So what did I just prove in the second part? So if I have an element y of order D, it is of the form y by k. It is of the form y by k, yeah, with k and d being co-prime. Okay, so you know that from tool, you know that every element of order D, is it 2? It's B. From B, we know that every element of order D, KD is equal to 1. KD is equal to 1. is of the form y power k. Okay? Now, how many such elements are possible? And here is what will give you the less than equal to that I'm looking for here. Yeah? How many such elements are possible where kd is equal to 1? This is the Euler-Free function. Okay? So, phi d is less than equal to phi of d. Now tell me why this still implies that z by pz is cyclic. A very well-known identity. Now, phi d, do you know this identity? N, if I take phi d, d divides n, what is this? This is equal to n. All right? Hence, sum of phi d minus psi d, this is for d dividing p minus 1 is equal to 0. All right? The group is cyclic. You knew it, I know, but you didn't know the proof. You didn't know this proof. All right? So here we are happy. Okay. Was it okay? You are tired. Yes. We will start tomorrow with something.